My name is Xiong. I'm assistant professor at the College of Information Science and Technology from Penn State. Today, I will present our work in progress. Drivers and passengers may be the weakest link in the CAV data privacy defenses. This project is through collaboration with faculty member from University of Virginia. The massive data collection and the use of connected autonomous vehicles, or CAVs, raise novel privacy and security challenges. Throughout the workshop today, we have heard a lot of discussion from the technologist perspective. While the privacy techniques of CAV are under rapid development, we argue that human factors of CAV privacy must also be understood and investigated. Using the human information processing approach, we characterize that drivers and other occupants' information disclosure behaviors via stages of privacy motivation, privacy awareness, privacy decisions, and actions. In this preliminary work, we make the first step in understanding a few factors at each stage that are unique for the CAVs. Individuals are motivated to share information online by various goals, such as economic benefits and psychological benefits, indicating a privacy and utility trade-off. Compared to the general online environment and the IoT settings, people have novel motives to share their personal information in the CAV context. Specifically, driving safety could become their primary motives for information disclosure. For example, people probably choose to share their onboard diagnostic information because they have concerns about fatal CAV accidents due to not sharing such kind of data. Therefore, the existing privacy utility trade-off becomes privacy utility and privacy safety trade-offs in the CAV context, which could make drivers and passengers become even weaker link in the CAV data privacy defense. Privacy awareness refers to people's attention and perception of possible risks throughout the interaction with an application or service that can gather and process personal information or data. Most communication of such privacy risks have been deployed using visual stimuli. However, drivers and passengers' visual attention is typically given to driving-related objects. Therefore, auditory stimuli, such as seatbelt buckle alarms, might be expected by the CAV users when signaling potential privacy risks inside and outside the CAVs. Given the safety-sensitive nature of driving, any decision-making or action selection in the CAV might also be time-critical. For example, the National Highway Transportation and Safety Association guidelines have recommended that tasks to be completed by driver while driving with glances away from the road of 2 seconds or less. Therefore, privacy decision beyond the current notice and consent should be considered in the CAV context. Moreover, we advocate that the privacy concerns of CAV drivers and passengers should be considered and proactively integrated into the development and the deployment of privacy-enhancing technology for CAVs. For example, users may have concerns about the cost of added noise from differential privacy on their driving safety and refuse to accept differential privacy. Therefore, when deploying differential privacy, it is important to consider user acceptable noise level and to be transparent on the utility cost, safety cost, and their implications. We believe the technology aspects and the human aspects are complementary to each other, both of which are critical to address the privacy challenges of CAVs.